In this section, we'll talk about between subjects experiments. So our key topics will be, what does it mean to be between subjects? And what is random assignment? There are two criteria, and we can also use block randomization, and we'll talk about matched groups. So consider the bystander effect study you read earlier. So you already know that in the experiment, each participant was assigned to a different condition. In one version, each participant could have been assigned to either condition 1, a smoky waiting room alone, condition 2, a smoky waiting room with an unconcerned Confederate, or condition 3, a smoky waiting room with 2 other participants. So this is an example of a between subjects design. The dependent variable, what they were measuring, which was the time before they sought help, was compared between participants in each condition, and no single participant was in 2 conditions. So what is a between subjects design? It's a design in which each participant is assigned to a different condition, and the dependent variable is compared between participants in each condition. So, quick example, of 100 university students, 50 are assigned to write about a traumatic event and 50 are assigned to write about a neutral event before the researcher measures their stress levels. And in this example, just to review some key concepts, the independent variable would be the writing prompt. Traumatic writing versus neutral writing are the conditions. And the dependent variable, what they're measuring, would be stress levels. They haven't operationalized it in this example. Another example, of 60 people with severe agoraphobia, which is fear of open spaces, 20 are assigned to treatment A, 20 are assigned to treatment B, and 20 are assigned to treatment C before the researchers measure a symptom reduction. The independent variable is the treatment, A versus B versus C, and the dependent variable are the symptoms of agoraphobia. And so in both of these examples, you can see that there are different people in each condition. And that's all we mean by a between subjects design. So there are some key components. Participants are assigned to different conditions. Participants in each condition must be highly similar to each other. That's what we're counting on. So each group or condition should be similar in terms of gender, the same proportion of male to female. In terms of race, it's the same distribution of races, or all one race. In terms of age, kind of the age range should be similar, IQ, or general aptitude, motivation, education, all these things should be similar. This is what a between subjects design depends on. And you can remember why from our last lecture, because otherwise we're going to have extraneous participant variables, and there's even a risk that they would become confounding variables, and that would compromise the integrity of the experiment. So how do we create similar groups? Method 1, completely random assignment. So random assignment in general means that we're using a random process like a coin toss for assigning people to conditions. So this is so often confused for students. Random assignment is different from random selection or random sampling. Random selection or random sampling means you're using a random process to choose participants. Random assignment means you're using a random process to assign people who have already been chosen to different experimental conditions. So don't get those terms confused. So random assignment must meet 2 criteria. First of all, each participant must have an equal chance of being assigned to each condition. So there's nothing systematic, it's just random what condition a person gets. And secondly, each participant must be assigned to a condition independently of other participants. So you can't decide to put, say, a couple of friends in the same condition just because they're friends. Everyone has to be assigned independently. The problem with completely random assignment is that you might get unequal groups, and you can picture why. If we have 2 conditions and we flip a coin, heads or tails, heads always goes to condition 1, tails goes to condition B, we know that we're not going to get the same number of heads and tails. I mean, we can predict an approximately equal number of heads and tails over a large number of flips, but we know it's not going to come out perfectly. We might wind up with unequal groups, and that can make just a little bit of challenge in statistics, especially if you have just a smaller number of participants. So researchers sometimes use techniques to avoid the potential problem of unequal groups. So one way to create similar groups without the problem of unequal group sizes that occurs with complete randomization, we can use block randomization. And in this method, we use a random process, usually this is computer generated, to assign each condition one time before any of them is repeated. So let's look at an example of how we might do this manually. So imagine that you have 3 conditions, and you want to get people randomly assigned to each of the 3, and you want equal groups. Well, you could take 3 poker chips, just 3, and write an A on one, a B on the second, a C on the third, corresponding with your 3 conditions, and put them into a bag. You could then arrange the participants into blocks of 3 participants each. Usually this would be done at random, and at a time usually when the participants aren't right in front of you. But whatever you do, this arrangement into the blocks would have to be random so that you don't have groups of friends together. And then in block 1, for participant 1, you would draw out a chip and return it to the bag. So maybe the chip you drew out is the A. And you don't return it to the bag, excuse me. You just record the A next to that participant's name. You do the same for participant 2. Maybe the next chip you draw out is the C. And you record that next to the name and leave it out of the bag. And the last chip, of course, is B, which is automatically assigned to the 3rd participant. So these 3 participants comprise the first block. And so this is block 1. And so if you continue this process, then you put all the chips back in the bag and do the same process over again for each block that you have. And so you would end up with something that looks like this. So here would be block 1. Block 2 would be here. You can see that the chips were drawn out B, then C, then A. Block 3 is here. And you can see the chips that were drawn out were C, and then B, and then A. And you'd continue that till everyone is assigned. So you can see how this is a nice randomization process that generates equal group sizes. So random assignment, if you're doing a between subject study, random assignment is at the backbone of your study. It is the strength in your study, and you should definitely use it if at all possible. You might think, well, if I use random assignment, the group still could be different in terms of age, in terms of gender. We don't know. And you're right, they could be. But randomization works surprisingly well at equaling out these group differences. And statistical processes also work conservatively, so meaning that it takes into account these possible problems with groups. So these kinds of things can be balanced out statistically. So if you're using a random assignment process, then you have a good, strong foundation for your study. Sometimes, though, you might be concerned about pre-existing differences within the group, and you might have a greater concern than normal. And in that case, you might use method 3, matched group designs. So matched group just means that we match participants in the various conditions based on a selected variable before manipulation of the independent variable. So what does that mean? Let's imagine a situation, this time with people with acrophobia, which is fear of heights. And let's say we have 2 different treatments. We want to help these people. But we know that each person has a different level of severity for their acrophobia. Some have much more severe worries than others about heights. And so one way we could eliminate concern about such pre-existing differences is by matching participants. So these are the steps we would take. We would take all the participants in the study, and at some point we would have gathered data to find out how severe their phobia is. And then we would rank them from 1 to 30 if that's how many people we had, from the most severe to the least severe phobia. Then we would take the first two people on the list, and these would be the two people with the most severe phobia, and we would randomly assign one to treatment A and one to treatment B. So it's almost like the block randomization, except the blocks are consisting of participants who have been placed in rank order according to the severity of their condition. So then we would take the third and fourth people on the list, and they would be sort of like the second block, and we would randomly assign them to either treatment A or treatment B, and that process would be random. And we would continue that process until every person is assigned to a condition. At the end of the study, then, if we find that one treatment worked better than the other at reducing the average symptoms, then we could say for sure, with a good degree of confidence, that it was due to the treatment differences and not to just arbitrary pre-existing differences in the severity of their phobia. So in summary, between groups designs mean that each person is assigned to a different condition. Random assignment is an excellent way to do this. We can use complete randomization, but there might be a concern about differently sized groups. Or we could use block randomization to achieve equally sized groups. Matched groups designs can be used instead of randomization to resolve concern about pre-existing differences.